Well, good morning, and thank you very much. It's really a privilege to be here with you. And indeed, I would like to explore this idea of data as a natural resource and foster a dialogue as to some of the implications. And I'd like to have the discussion of data as a natural resource, perhaps by sharing with you an example of a piece of work we've done out of the research division in IBM, working with the Beijing Environmental Protection Bureau. And here, the challenge that we took in collaboration with the Bureau was to explore how we could deploy a new generation of sensors and use advances in modeling and artificial intelligence to help provide decision makers and policymakers with the instruments to mitigate the level of pollution increases that we're seeing in the city, in Beijing and other cities across China. And in this case, as an illustration of the power of having access to the right data and applying the right models, the methodological approach we took here was broad deployment of instrumentation, the ability to track and identify the sources of emissions, and that's its own project in its own right. And then, interestingly enough, create a very high-resolution forecast that originally went 3 days ahead, and now we've improved to 10 days ahead. And the ultimate goal is actually to take action. And in this case, it's a tool, just to give you a highlight, what you're seeing on the left-hand side, is a tool that now the decision makers can utilize to create different scenarios of what happens if you shut down sources of emission. And this could come after you've done attribution from unregulated sources of production of emissions that generate a high particle count, but also other control mechanisms that may impact the productivity of some of these factories, but are necessary actions that one has to take if the weather conditions actually can lead to bad outcomes. And what you're seeing here is this methodology of a very data-centric approach to decision-making, leading to improvements, right, that have been attributed to be able to generate these kinds of tools, about an 18% reduction of 2.5 micron concentration particles. And it's an example of a technology now that is being rolled much more broadly. But I use this as an illustration of a movement that is going on, which is data science for social good. And perhaps we can think in the context of this conference to what role data and data science for a good Anthropocene is going to play a central role of progress and deploying technology in the right context. So I give an example where you can find more projects that we're pursuing, but it's a broader movement actually that University of Chicago and others really started, which is how do we attract talented data scientists and people who have expertise in AI and machine learning towards tackling very important goals broadly in society, and not just the deployment of these techniques only for improving advertising and all other areas. So I think that this is something that I think this community could also embrace and foster and channel the energy that a lot of these data scientists have towards a good goal. So I bring it up as an opportunity for improvement. I want to talk a little bit about AI and the centrality of data in the revolution that is happening in this field. First, I'd like to put it a little bit in context that the AI story has been a long time in the making. In fact, the biological inspiration from some of the neural networks that are coming into fame right now trace back to the very beginning of the 20th century when Santiago Ramón y Cajal and other neuroscientists were able to inspire us and understand how in our brains we have neurons and we have axons, and the intersection of axons from synapses, and that the learning process is related to the formation of those synapses. And there was this mathematical abstraction from that idea that took place in the 1940s with the creation of artificial neural networks. I mean, it wasn't more sophisticated than that level of biological inspiration to create these networks. And they really thought, the scientists at the time, that they had this crack, that actually in a few summers they were going to solve the problem of general intelligence with computers. And needless to say, that was quite wrong. And the field of AI has gone through many, many winters of tremendous excitement that these approaches of creating these artificial neural networks was going to be the basis of learning through examples and data, and leading to disappointment. But here's the thing. That whole idea finally works, and it's not because of an algorithmic revolution. It has to do with two other trends that are quite fundamental. And the reason is one of the major trends is just pure advances in computing power. It turns out that for some of those neural networks to work and to learn by example, so I want to contrast that with the traditional computing methods of learning by programming, right? I mean, so where a person would imagine a process that you want to automate or a process that you want to assist another human being, and you have to imagine all the steps that happen and write a program that executes those steps, and then you get the improvements of efficiency. But in this example, you don't know how it works. You're just feeding it examples of what happens in the world. And by properly training the network, it generalizes and is able to solve that problem. That's a fundamental transition. One major trend of why now is just computing power. It turns out some of these networks have as many as 1 billion adjustable parameters. And if you've heard about this term called deep learning within this space, it actually has to do with that idea that you have many, many layers on this network. So it turns out the size of the network was quite important. Another trend that is really going on is that because they're starting to work, you're seeing extraordinary amount of talent shift into this. If you look at, for example, at MIT, it's turned out that now the Introduction to Machine Learning is the most popular course in the history of the institute. So basically, I think out of the incoming class of 1,100 students, 700 and something want to register to take it. So it's becoming, what I'm going to argue is that computing power is going to be available. If we want to provide enough computing power for every citizen in the world, there's a way to technically solve that problem. There is going to be an increasing amount of talented people who are going to generate more models, and I'm going to argue that the models are going to be quite public, and a lot of people, or all of us, will have access to them, to what is the underlying mathematics. That is not going to be the secret sauce. The issue, the centrality of this is going to be the data. Who has access to the data? And data is exploding as a natural resource. So this is the best projections that we're able to make on how data is going to grow. And if you look at, by 2025, we will have on the order of 165 zettabytes. So that's 10 to the 21. So, and the reason it's happening is because we're increasingly instrumenting the world with more and more sensors and devices, and every profession is involved in digitization and access to these systems. So this is going to present a lot of fundamental questions. So again, take for a moment for granted that computing is free, that those algorithms to train and be able to codify expertise and be able to deploy it will be broadly available. So the question is, how do you train those systems? Is the data fair or is it biased? Who has access to it? And if we think about back to this analogy of natural resource, well, what happened with natural resources? What is the role of government and the state in relation to the natural resources? Should natural resources be concentrated in just one firm, like the equivalent of state oil, at the time of oil, or what is going to happen with data? I think these are a lot of profound questions that I'm hoping we'll get a chance to also explore. But my advice would be to not get confused by the illusion of this magical AI that is happening, right, as if it's a secret sauce. While sophisticated, it's not that complicated. It really can be understand what is being used. The central question is the data. What data you collect to train it, who has access to it, what's the quality, and how does it get used, and who benefits from it. Thank you.